Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome again to the TV learning programs. This is Teacher Pasco. Today I will be with Senior 1 students, and as usual we'll be learning chemistry. If you remember well, we have started and we have been studying lessons in unit number 6. You can see here we have unit number 6, the arrangement of elements in the periodic table. And today we shall have the second lesson, that is metallic and non-metallic trends in the periodic table. There is a lot we have studied in this unit, in the first lesson, and we will go through that again as a revision before we start the new lesson, the metallic and non-metallic trends in the periodic table. But before we go any further, let me take you through the objectives of our lesson so that you can know what you are supposed to know at the end of this lesson, what I'm expecting from you. At the end of this lesson, you should be able to state the trends in metallic and non-metallic character of elements across a period and down a group of the periodic table. Of course, here I've written state, but you should also be able to explain. The trend you state, you should be able to explain why it is like that. And number 2, you should be able to relate metallic and non-metallic properties of the elements to their position in the periodic table. Elements have different positions in the periodic table. So is there any relationship between the metallic and non-metallic properties of the elements and their respective positions in the periodic table? We will have a look at that, and you should also be able to explain how it is like what we will see. Now, let us start with the correction of the homework. The homework I gave you at the end of the previous lesson, the last lesson. The first question was to explain what is meant by a triad. What is a triad? Explain what is meant by a triad. What is a triad? I hope you have tried the exercise. So what do we call a triad? Do we remember the scientist who suggested the classification of elements in triads? De Bruijn's triads. So a triad, if you remember, it is a set of 3 elements which have properties which are related, which are almost similar, which can show a trend in the variation of the property. And we have seen that in the triads, elements, the 3 elements we consider to be in a triad, that set of 3 elements, this element which is in the second position, or which is in the middle of the triad, it has properties which are almost the average of the properties of the other 2. So I guess here I'm not explaining, but maybe describing what a triad is and some of the characteristics of a triad. Of course, when we are correcting the homework, it is the right time. We can also have a revision. So I hope you have understood what a triad is. A set of 3 elements which have similar chemical properties and physical properties, and almost similar, of course, and which have been suggested by a scientist called De Bruijn. Question number 2. Explain how Dmitry Mendeleev classified elements. You remember Dmitry Ivanovich Mendeleev? It's a Russian chemist who classified the elements in a current order, but who also predicted the properties of the elements which were not discovered by that time. And he classified elements according to what? Do you remember what he considered to classify these elements? He classified the elements according to the increasing mass numbers of the elements. And he realized that when they are classified according to the increasing mass numbers, the elements and their properties could show a regular pattern of, or what we can call the periodicity of the properties. So elements with similar properties could be coming at regular intervals in the classification. So there was a certain periodicity when these elements were classified according to the increasing atomic mass or mass numbers. So that is how he classified the elements. You remember, he classified the elements in groups and periods. In the periodic table we have groups and we have periods. And very soon we will see how these groups and periods are related to the electronic configuration of the elements. Now let us go to question number 3. To which group and period does magnesium belong? Remember, we said that to know a group and a period, we have to use the electronic configuration. But before we write the electronic configuration of magnesium, I want you to recall what a group is and what a period is. I hope you have taken your periodic tables, because we cannot learn the arrangement of elements in the periodic table without using the periodic table. So let's go to the periodic table and look at what a group is and what a period is. What is a group? Remember, we define groups or families as those vertical columns. The vertical columns. If you consider at the left part of the periodic table, you will see that we have a vertical column, the first one, which contains hydrogen, lithium, sodium, potassium. That is a group. So the vertical columns, we call them groups or families. And the horizontal rows, we call them periods. We have 7 periods in the periodic table. For example, you can have the third period, which contains sodium, magnesium, aluminium, silicon, phosphorus, and so on, up to argon. So that is a period. Now, let us write the electronic configuration of magnesium so that we can deduce the period and group to which magnesium belongs. Magnesium has the atomic number 12. And the electronic configuration, we have electronic shell number 1, K, L, M, N. We know that in the first, we can have a maximum of 2. So we have 2. And after writing 2, we are remaining with 10. The second one can have a maximum of 8. And after using this 10, what remains is 2. So in the third, we have 2 electrons. This is the electronic configuration of magnesium. Now, how do we determine the group number of a given element from the electronic configuration? You remember that. We use the number of electrons in the last shell. Which one is the last shell? It is M. And how many electrons do we have in the last shell? We have 2 electrons in the last shell. And the number of these electrons in the last shell is equal to the group number. So magnesium belongs to group number 2. group 2. Okay? Group 2. And how do we determine the period number? We consider the number of shells which are occupied by electrons. How many shells do we have in magnesium? We have K, that is the first, the second, and the third. So we have 3 shells. And the number of shells is always equal to the period number that the element belongs to. So it belongs to period number 3. I hope it is very clear. So magnesium is in the second group based on the number of valence electrons it has, and it is also in period number 3 based on the number of shells, electronic shells, it has. And the last question here, state any property shared by all elements in a group. What is shared by all the elements in a group? We have seen that in the last lesson we had on this unit. And we said that all elements in a given group, they have, for example, the same number of valence electrons. They have similar chemical properties. But here let us focus on the group number. For a given group, remember, to find the location of a given element, we consider the valence electrons. So in a given group, all elements should have the same number of valence electrons. And in a period, what do they share? Remember, they have same number of electronic shells. That is what we have said on the answer of this third question. So in a group, all elements have the same number of valence electrons, and in a period, they have same number of electronic shells. Very good. Now that we have revised what we studied, what we covered previously in this unit, we can go to the next part of the same unit. The new lesson, metallic and non-metallic character. But before, remember, the title of this lesson is The Trends in Metallic and Non-Metallic Character. But before we look at the trends, let us find out what metallic character is. What is metallic character? What is metallic character? Here there is a definition. Metallic character is a measure of the tendency of atoms to lose their electrons. Remember, we have seen in unit number 5 that monoatomic radicals exist, and they are formed when atoms lose electrons or gain electrons. We know that when an atom loses an electron, it becomes positively charged, and we call it a cation. And when an atom gains an electron, it becomes negatively charged, and we call it an anion. So we can use how easily an atom tends to lose or tends to gain and classify the elements. And we can classify the elements in metals and non-metals. But of course, in the group of metals, all metals will not be metallic to the same extent. And the non-metals will not be non-metallic at the same extent. So that is the reason why we get what we call a trend. Here, let me repeat the definition. What we call metallic character: a measure of the tendency of atoms to lose their electrons. From this, non-metallic character here there is NON, it's non-metallic character. Non-metallic character can be defined as a measure of the tendency of atoms to gain electrons. So non-metals tend to gain. They easily gain, the non-metals. But metals lose easily. So the metallic character is very high in the metals, and the metallic character is very low in the non-metals because they have a very low tendency of losing electrons. Instead, they have a higher tendency of gaining electrons. And because of that, we say they have a low metallic character, but high non-metallic character. I hope it is clear. Now, let us have a look at how the metallic character varies in the periodic table. Across a period. Remember, across the period, it is when you are moving from one group to the next. From group number 1 to group number 2 to group number 3 in a given period. Period number 3, for example, when you are moving from sodium to magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Those are the elements we have in the third period. And what happens? As one moves from left to the right across the period, metallic character decreases. And why is it like this? Metallic character. Do you remember what metallic character is? The ease or the tendency of losing. But if you know this chlorine, for example, do you remember sodium and chlorine? What is the charge on chlorine? Remember, it is 1 negative. And here it is 1 positive. Why is it 1 negative here? It's because chlorine has gained. Why is it 1 positive? It is because sodium has lost. Now, between sodium and chlorine, which one has a higher tendency of losing? Of course, it is sodium, which has become positive because it has lost. But chlorine, which is negative, has gained. So you can see that from sodium up to chlorine, the tendency of losing is decreasing, while the tendency of gaining is increasing, as sodium can lose an electron, but chlorine will gain the electron when making a compound. This is an easy example of showing how the metallic character is changing. Remember, we can have a compound like magnesium chloride. Magnesium which has 2 positive and chlorine which has 1 negative. This is metallic and this is non-metallic. It is the same for sulfur. I hope you remember the radical which is the sulfide with 2 negative, showing that it gains. So as we move from the left side of the periodic table to the right side of the periodic table, metals or elements become less metallic and more non-metallic. So we usually find that on the left side we have metals, while on the right side we have non-metals. Okay? On the left side we have metals. For example, sodium is metallic, magnesium is metallic, aluminium is metallic. I hope you know some materials which are manufactured using aluminium, like the saucepans, for example. A saucepan, or the aluminium foils, those foil we use to cover food. So you can easily see that they are metallic. The saucepan is metallic. The cover is also metallic. So Metals are on the left side of the periodic table, while non-metals are on the right side of the periodic table. And let us explain why it is like this. This is because the attraction between valence electrons and the nucleus becomes stronger. The attraction between the valence electrons and the nucleus becomes stronger as you move across the period. And you can imagine what will happen, what will be the consequence of that stronger attraction. If an electron is experiencing a very strong attraction, then it cannot be easily lost. So that is the reason why the metallic character, which is that tendency of losing electrons, will decrease as you move across the period. Why? Because the attraction is becoming stronger. The electrons are experiencing a stronger attraction. And this, in turn, will make the loss of electrons difficult, hence a decrease in metallic character. So moving across the period, the electrons will be experiencing a stronger and stronger attraction, so that it is very hard for argon, for example, to lose its electrons. It is very hard for chlorine to lose its electrons. Instead, it will gain the electrons. And if we look at what happens down the group, we find that as one moves from the top of a group, here I will use sodium, potassium, rubidium, and cesium. Which of those elements will tend to lose the electrons more easily? So the one which loses more easily is the one which is largest. You know, if something is very far from you, it is very easy to take it from you. If I want to take something from you, I would start with what is very far from you. And that is what happens even with the atoms. When an atom becomes larger and larger, it is very easy to take off the electrons because the electrons will be experiencing a weaker attraction. Okay? So, when you move down the group, the metallic character will increase. It is very easy to lose the electrons because the size is very large. And here it is being said, it is because the attraction between valence electrons and the nucleus is becoming weaker. It becomes weaker because there is an extra shell which is added. And then this makes the loss of electrons easier, hence an increase in metallic character. So moving from sodium to potassium, rubidium, and cesium, the metallic character increases. So cesium will lose electrons more readily than rubidium. Rubidium more readily than potassium, and potassium more readily than sodium. The metallic character increases as you move down the group. The ease of losing electrons increases as you go down the group because the size is increasing. We have more shells. Remember, as the number of periods is increasing, we get more shells. And then the metallic character increases. Now, from this, how can we relate that to the position of the elements in the periodic table? Here we have position of elements in the periodic table based on metallic character. Here we have the left side. You can see in the blue color, here in the blue color, all these are metals. So on the left side of the periodic table, we have metals. On the right side, in the yellow color, we have non-metals. those which lose very difficultly. But between the metals and the non-metals, we have metalloids. This group of metalloids, we call them metalloids. Why? Because they have both characters of metals and non-metals. Sometimes they may behave like non-metals, and other situations they may behave as metals. So they have characters of both metals and non-metals. On the left side of the periodic table, there are metals, the elements whose atoms lose electrons easily and gain very difficultly. This side. Here there is hydrogen, which is a non-metal, but we place it in the first group, even if it is a non-metal, because it has a single electron. And here, so that is an exception. Secondly, here, on the right side, this right side, we have elements which are non-metals, and they will always lose very difficultly, while they gain very easily. In the middle of the periodic table, there is this set of the metalloids, and I said they are called metalloids because they have properties of both metals and non-metals. So let us have a look at the work you will try when you get time. You should always try to find time to exercise. We always say, practice makes perfect. So you should always exercise. Here is your homework. Let me remind you that if you don't have the ability of writing too fast and you can access a smartphone, you can take a picture of this slide. What is a metalloid? You will explain what a metalloid is. Explain how metallic character varies across the period. We have seen that. And how does non-metallic character change in a group? The non-metallic character, which is the opposite of metallic character. And here you will state how it changes, the trend, and you explain your reasoning. Which one between magnesium and sulfur is more likely to lose electrons? You will focus or base your thinking on the metallic and non-metallic character. And here you will explain your answer. And the last, but not the least, of course, which one between fluorine and iodine would gain an electron more readily based on non-metallic character? And you explain. I hope everything has been explained very well and clearly, and then let me say thank you for your attention. Thank you for always being there to follow the TV learning programs. You are doing a great job. Keep it up. I hope to see you next time. Safe and sound. Thank you very much. See you next time.